understand. So this is the general follower regulator circuit. This is your base. Okay, this is your ammeter. This is your collector. C. I am applying some input here. Say value is 20 volt. 20 volt input I am applying here, and the value resistance is given. Is given. VBE you can take 0.7. VBE. Okay. This B to E you can take 0.7. VBE. And the VZ is given for the Zener diode is 10 volt. Now, if this Zener is on, then automatically this point VB, okay, this will be 10 volt. And if I apply output equation in this circuit from minus VZ, if it is on, then this is a 10 volt, 0.7 volt, and automatically this voltage will become fixed. If this voltage is become fixed, if this gets fixed, then you know that you can find the current. What is IE? Once you know the current IE, which is here coming from ammeter, which is equal to the load current, which is equal to IC, and if you know the IC, you can find, if beta is given, you can find how much IB is going. Okay, if IB you know, IC you know, okay, and also you can find what current is coming here. I current is coming here in this circuit, in this Zener diode. So let us say a current is flowing I here in this circuit. Okay, of course there is some current coming from here. C is also IC also is there, and then I is coming here in this circuit. So first job in the circuit is to be able to find whether the Zener diode is on or off. Okay, tell me whether it is on or off. How to find whether it is on or off? So in order to find, first you have to check whether this is working or not. Okay, so you have to make it open. You have to make it open, and you have to find what is the voltage is coming here by applying this input coming from here, coming from here and going for here. Okay, so basically what you have a minus B input in the beginning. Okay, then in this I'm coming from this circuit, and then you're coming from I into 680 ohm plus VB is 0.7 volt. Okay, and then you have a IE here. If I open this one, now this current become IB. This I become IB for me. So IB into 60. Okay, and this is my ammeter current, which is ammeter current is IE, which I can write beta plus 1 IB. Okay, beta plus IB into 15 ohm. So IERE 15 ohm beta plus 1 beta plus 1 IB equals to 0. Now if beta value is given in the question, how much beta is given 80. So this beta value is given 80 degree 80. So you can find what is the current IB. Calculate the current IB and tell me how much current is coming. So what is the value of IB here? This is 80. Okay. So IB will be what? IB will be what? 20 minus 0.7. Okay. This is 680 ohm plus this is 81 into 50. 81 into 15. Tell me how much value is there? What is the value? This 20.7 become 19.3, and 680 into 680 plus how much? 15, 1, 15, 1, 5, 120, 125, 125. Okay, this will come, and this will be 19.3. Okay, 1255, 680. How much coming? 39, 1935. Tell me what is the value of IB?
0.0009.
0.009.
Nine.
And this is the IB, and this IB is flowing here. Okay, so drop in 680 ohm, IB into how much? IB into 0.00, whatever I'm saying is, if it's correct. Okay,
So correct है ये
so 0.009. Okay, multiply with the 680 ohm. How much voltage is coming? This just for checking.
6.74 volt.
5,
6.74.
6.74 volt. Okay, so 20 minus, so this voltage coming 20 here. Out of 20 volt, this is getting lost here. 6.7 is getting lost here. 20 minus 6.74. Remaining is coming here, which is greater than your 10 volt. So when it is greater than 10 volt, automatically you say this Zener diode is on. So our job is finished. Okay. So just this for just checking. You have to check the Zener is on or off. So it's looking like
सर ये
that it is on.
नोट कर लो, मैंने नोट नहीं किया है.
So this is on. Other student, please also find out whether Zener is on or not. So for that, you find this voltage and drop this one. 20 minus this will come this.
सर ये 0.0099 है ना, इसको हम
One
0 पॉइंट नहीं इधर आई, हाँ 99 है ये.
0.01 कर सकते हो,
तो हाँ
0.01.
पर इसको 0.01 कर सकते हैं इसके लिए.
0.01 कर सकते हो ना, 0.01 कर सकते हो. And this is become 6.8 volt. 6.8 volt हो जाएगा.
अभी
6.8.
6.8 आ रहा है. यस.
हाँ 6.8 हो जाएगा, तो 20 minus 6.8 या 14.2 volt हो जाएगा. Okay, so basically just check करना है आपको. This should be greater than 10 volt. Okay, so now once this is done, you can convert this by a battery of 10 volt. Okay, now you can apply, you can say minus 10, this minus 10 plus 0.7 BBE. Okay, plus V naught equals to 0. So my V naught become 9.3 volt. That is the thing. Okay, now once V naught is known, everything is known. So if this V naught is known, you can find what is the current IE, which is equal to IEL, that is 9.3 divided by 15. This will come 0.62 ampere. 0.62 ampere, and this is just like same like a IC. So IC will be also 0.62 ampere. Now you can find the IB. IB will be divided by this one, 80. Okay, so IB will be your 0.62 IC upon beta. 0.62 divided by 80 will come out 7.75 milliampere. Check it.
यस रियल.
Now IB पता चल गया आपको. Now what you want? So now this is corrected. You know this IB. And can you find this I? You can find I. Now you can find this I also in the circuit. This I from here. So I will be what? I will be 20 minus 10 upon 680. Okay. So 10 upon 680. How much milliampere? I, tell me. 14.7. So this will come out as a 14.7 milliampere. Check it. So if you know this, okay, Here I'm applying this circuit. And if you know this IE, you know how much IAB is going here. Okay. And now you can find what is IZ. So IZ will be simply I minus IB. 14.7 minus 7.75 milliampere. Tell me how much will come. 6.95 milliampere. 6.95 milliampere. Okay. Now, if you want to find VCE, so VC is already given. This is C, the collector C, 20 minus ammeter load V naught.
7.15 है।
कौन सा वाला?
ये वाला आईजेड आईजेड।
7.15 आएगा?
यस सर। 40.7 लिखा है ना आपने?
हाँ।
फिर ठीक है, फिर ठीक है, फिर ठीक।
एंड VC कितना आएगा? V लोड कितना निकाला था हमने? V लोड था हमारा 9.3. This V load is equal to VE 9.3. So this will come how much? 10.7 volt. So you know VC, you know IC, you know the operating point now for this circuit. Let us do one more problem of similar kind.
सर
हाँ,
सर मैं थोड़ा 5 मिनट लेट था, आप बताओगे हमें इसमें फाइंड क्या करना था सर्किट में, मतलब कैसे इसको फॉलो किया हमने?
भी ये वोल्टेज फॉलोअर सर्किट है,
ओके।
रेगुलेटर है। अगर यहाँ का वोल्टेज फिक्स हो जाता है
हाँ
तो
हाँ।
यहाँ का वोल्टेज फिक्स हो जाता है,
हम्म
यहाँ का वोल्टेज जीनर के बराबर हो जाता है।
हम्म।
we VB loss करके if this is your 10, this is 0.7, so this become 9.3,
यस सर।
and this is always fixed.
हम्म
Once this is on, यहाँ you can keep on changing here.
हम्म।
ये अगर ऑन है तो ये वोल्टेज फिक्स हो गया।
यस सर, यस सर।
ये रेगुलेटर वोल्टेज रेगुलेटर सर्किट है। ओके,
यस सर, थैंक यू।
so let us do one more problem. BC 20 volt. This is 220 ohm. This is 12 volt. Okay, and you want to find the V naught. Let us find V naught. So again the same thing. First you have to check whether this zener is on or off. This 20 volt is coming from here. Okay, this 20 volt basically coming from input. This 20 volt. So this is 20 volt automatically. So we can again apply this one. We can open it and we can check whether this is on or off. So that is your homework. Okay, but I am assuming this is on. So once this is on, this become 12 volt. Okay, so my V naught become how much? My V naught will become this V naught. This is the VB. So V naught will become 12 minus BZ minus VB. 12 minus 0.7. How much?
11.3.
11.3 volt. Okay. So this checking you have to do. Otherwise, everything is very easy. So if this is known, V naught is known. You know the current IE or IL, that is 11.3 volt divided by 1 kilo ohm, that is 11.3 milliampere. Okay, and you can find the current flowing, this current I flowing in the circuit. So once you know the IE, if beta value is given, beta is given in the question, how much? Beta is given 500. Beta is given 500. So you can find your IB. IB will be IC upon, so this is equal to IC also. So beta, this is 11.3 milliampere divided by 500, and this will come out around how much?
22.6 microampere.
22.6 microampere. Okay, 22.6 microampere और मिली एम्पियर में आ जाएगा 0.00226 मिली एम्पियर.
0.0226 है, जीरो से मिली आएगा.
Okay, and you can find I in the circuit. I is how much? I will be your 20 minus 12 upon 220. So 8 upon 220 कितना मिली एम्पियर आ रहा है? I is 36.4 milliampere. 36.4 milliampere. Here. So you have IB, you have a I, you can find IZ. This IZ, because this I is coming here, IB is going up, IZ is going down. So IZ will be your I minus 36.4 milliampere minus 0.0226. Okay, which is equal to 36.2 milliampere. So now you have this, you have VC, you have a VC, and you have a VE. Okay. So you have a VCE, you have VC minus VE, that is 20 minus VE is 9.7 volt. 8.7, 8.7 volt. 8.7 volt. And you can find other parameters also if you want. Okay. So this is your voltage regulator circuit. So it's simple. Now we'll go to the next application. So the next application is Darlington pair. So Darlington pair means now two transistors will come in couple. Couple means their one transistor base and other transistor emitter will be connected. So if I say this is my, so this will be this type of connections. And this type of transistor always comes in a pair. So suppose say here current is coming IB1. Okay. So this is your IC1. and this is coming IE1, and if this is the beta 1 for given transistor, and the current gain is beta 2 for this transistor, okay, and this current, if I say this is IE2, and this current I say IC1, okay. Now automatically I can write here, because this IE1 is a basically IB2, okay. So suppose if I want to write this current IE2, so IE2 is nothing, it is a beta 2 plus 1 IB2, because I is what? IC, IC, IE is what? The IE1 is basically your IB1 plus IC1. Similarly, IE2 is what? IB2 plus IC2. Okay. And in the given question, given circuit, automatically your IB2 become IE1. Okay. This current is a meter current of first. So IE2 is your beta 2 plus 1 IB2, and IB2 is nothing. IB2 is what? Beta 2 plus 1. IB2 is your IE1, and IE1, what I can write? The IE1 I can write beta 1 plus 1 IB1. Similarly, IE2, what I can write? Beta 2 plus 1 IB2. So this is beta 2 plus 1 I1. So this become beta 1 plus 1 beta 2 plus 1 IB1. Okay. So this is my IE2. IE2. Okay. So in this type, I can amplify my gain in multiplication. So two transistor connected in such a way manner are called your Darlington pair. So here you can find beta may be same, beta may be different, and this equation also you can sometime you can use like this. If you neglect this one, so you can write beta 1 beta 2 equal to IB1. This way also you can calculate if beta is very high compared to 1. So let us solve one problem.
We have to find here IE1 and IE2.
I want to put IE2.
IE2.
Okay. So let us solve one problem. So say this circuit is connected to VCC. Okay. Here a resistance, we have one resistance here, and we have one resistance here. This is a 20 kilo ohm, this is a 10 kilo ohm. Okay. And now here one more resistance is given. This is 60 ohm. Okay. So solve the circuit, find the values. Beta is given 100 for both the things. Beta is 100. Beta 1 is also 100. Beta 2 is also 100. Okay. And VCC is given as a 15 volt. So you can simplify this circuit by how can you solve? Because here no resistance is there. In this circuit there is no resistance.
सर
Tell me.
सर ये जो RE2 है उसकी वैल्यू क्या है? RE2
R
E2
IE2.
R the resistance value just down to that.
Here.
उसके just नहीं जो उसके नीचे है।
It's 60 ohm, 60 ohm. And if you want, you can connect this one also here. Okay. Now, how to solve this one? How to solve this one? I want to find IE2. So, tell me what is the voltage coming here? VB, tell me what is the voltage here, VB? What is the voltage here, VB?
10
So,
volt,
either, huh?
10 volt आएगा
10 volt. So, either you can do R Thevenin, okay, or even you don't require to do R Thevenin here. If you want, you can do the R Thevenin here. Otherwise, this 15 is getting dropped here and here. So here this will be okay. BC, we say this is VB. So BB will be what? BB will be your VCC upon R1 plus R2 into R2, and this will come 15 volt, 15 upon 30 kilo ohm into 20 kilo ohm. Okay, so this will come 5. This 10 volt. So this is your 10 volt. This is 10 volt. Okay. Now here you can apply KVL. This one. This will act as a battery. Okay. So you can write -10. Here you have a BBE. BBE1. Okay. BB1 and directly come here BBE2. BBE2. Okay. And then you can come directly here IE2 into RE 60 ohm plus 0. From there, you can directly find what is IE2. IE2 will be your 10 minus 1.4 divided by 60. Okay, how much is coming? 143 milliampere. So this is 8.6 divided by 60, 143 milliampere. Okay. Now, once you know the IE2, okay, you can find, I told you IE2 is what? IE2 is your beta 1 or beta plus, accurately beta plus 1, beta 2 plus 1, IB1. So you can find IB1 equals to 143 milliampere divided by what? Beta 1 plus beta 2. So this is what? How much will come? Tell me. 101 into 101. You can find this one, IB1. Similarly, you can, if you want to find IB2, so IB2 is simply, IB2 is your IE2 upon beta 2 plus 1. So like this, you can find everything here. And if you want to do little bit more accurately, then you can put one R Thevenin here. This circuit, you can put a R Thevenin here. But that will not change much because IB1 will be very less. So this answer will not change much. Because you can cut this circuit from here. This battery is here. So open circuit voltage will not change. And the parallel of this 10 and 20, how much will come? Parallel of 10 and 20, R Thevenin. So R Thevenin will be your 10 kilo ohm, 10 into 20 upon 30. Okay, that is 20 upon 3, that is 6.67 kilo ohm. So if you want, you can remove this circuit here. Okay, and you can put like this 6.67 kilo ohm here. Okay, and here you can put a battery VThevenin, that is 10 volt. And now first you solve the circuit for IB1. Or solve the circuit for IB1. Okay, and then you can find the value IB1, and then from there you can find value I1 and I2. Okay, so it's not changed much. How much is coming IB1 now? Tell me.
14.01 microampere.
14.3 microampere or 14.1 microampere? 14.3 microampere. So you can do one time this way also. You'll see it will not change much. Okay. Now one problem from the similar circuit came in exam that we'll do. Okay. So every student has to do this problem. Now this is your this is 580 ohm. Beta 2 is given 20. Beta 1 is also given 20. Okay. This is this is 220 kilo ohm. This is here. This is VCC. This is 1 kilo ohm. Okay. Now you need to solve the circuit. And you need to find what? You need to find this VC. This VC. So this problem came in exam, and VCC value is given 12 volt. VCC value is given 12 volt. And you want to find this VC. So from here you can see if this is the transistor 2, okay. So if the current is flowing in this transistor, and this is also connected, just give me 1 minute, VC. Sorry, this is circuit is like this. This connected here. This circuit is connected here. Okay, and this is connected here. Now it's easy to solve. So basically you want this VC, okay, and you know current is going here. This current is going here. Okay. This voltage right going here. One current is going here. This is IC1, and one current is going here, IC2. If I say this current is I, because this resistance, this circuit here, some current is coming I, IC1 is going here, IC2 is going here. So what I can write? I can write my I is equal to IC1 plus IC2. Okay. Now I want to find this VC. So this VC is simply what? This VC is simply, this voltage is simply 12 minus I. Okay. I into this resistance 1 kilo ohm. Yes or no? Tell me. This VC I want to find out. So this VCC is for 12 minus VCC minus this drop will become this voltage. Okay. Now if I want to find this voltage, I need to find this I. That means I want to find IC1 and IC2. Okay. So say this current is IB1. This current is IB2, which is equal to, of course, IE1. IE1 for first, and this become your IE2. This current become IE2. Okay. So I will solve this circuit. I'll find first IB1. Okay. So I'll solve the circuit, this one circuit. So this will come minus 12 plus 220 kilo ohm into IB1, this IB1, okay, and then you can take 0.7, this is 0.7 plus 0.7 drop, this one, and then this 0.7 drop, 0.7 plus 0.7 plus what? This is your beta 1 plus beta 2 plus 1, IB1 equals to 0, and this will give me the value of IB1. So IB1 will be what? IB1 will be 12 minus this 1.4, and this is 220 kilo ohm plus beta 1 and this 580 ohm also, this RE into 580, beta 1 plus beta 2 into 580 into 580 into IE2, okay, IE2 now IB1 equals to 0. So this becomes 12 minus 1.4, this 21 into 21 into 580, okay, this is the value of IB1. Please find the value of IB1. So are you getting what I'm doing here, students? Ajveer, Palak, Swar Pandika?
Yes, sir.
I'm starting from here. This is minus 12. Here current is flowing IB1 into this one, then this voltage and this voltage. Okay. IE2 I can find in terms of IB1, beta 1 plus beta 2 plus 1. If once I know this IB1, automatically I know what? I know IC1. IC1 is what? Beta 1, IB1. Okay. And if I know IB1, I know IE2, IB2, because IB2 is what? IE1. Okay. If I know IC1, automatically I know IE1. And if I know IE1, I know IB2. And if I know IB2, then what I know? You can find every quantity. So basically, if you know IB1, okay, then you can find IE2. IE2 is beta 1 plus beta 2, okay, IB1, and IE1 will be equal to I1 will be beta 1 plus IB1, okay, or you can directly find IC2 equal to what? IC2 equal to beta 2 IB1 and IC1 is equal to beta 1 IB1. IC2 will be what? IC2 will be beta 1 plus beta 2. IC1 will be beta 1, beta 2 IB1. Yes or no? Tell me. It is correct or not? If I want to find IC1, if I know IB1, I can find IC1. And if I know IB2, IB2 is what? IB2 is what? IB2 is your beta plus 1 IB1. So my IC2 will be beta plus 1. Sorry, beta plus this become IB. So beta 2. Sorry, this IC2 will be beta 2 into IB2. Beta 2 into IB2, and IB2 is my beta 1 plus 1 IB1. So this become my beta plus 1 beta 2 IB1. So you can use these two formulas and put the values here and find the total current I, and then subtract by this one, and you can find the VC. Tell me how much total current is coming I.
So the resistance is 580 ohm or kilo?
580 ohm.
Okay.
580 ohm. So
जी,
circuit is huh?
अपनी IC2 क्या लिखा है? IC2 क्या लिखा है यहाँ पे? बीटा 1
IC
प्लस,
beta 1 plus 1
ओके, आगे,
into beta 2
ओके, ठीक है।
into IB1. Because once you have find IB1, directly you can write IC1. IC1 is what? Beta 1 into IB1. Now similarly, if you know IB2, you can write directly beta 2 into IB2. You can know IC2. So beta 2 is basically IE1. That's why I written here is a beta 1 plus 1 IB1. So roughly, if you want, you can put just beta 1, beta 2, and this beta 1 IB also, but this will give you accurate value. So you can put this value and tell me what is I. So I'm putting the value I for me is 9.798. IC1 plus IC2 is 9.798 milliampere. Is approximately this one. Because you have already solved this one, IB1. How much is coming IB1? Tell me.
23.7 माइक्रोएम्पियर,
23.7
माइक्रोएम्पियर, यस।
microampere. Okay. So let us assume this value is correct. So I'm erasing this one. So if I erase this one, so this you have a 23.6 microampere. So you can write what? You can write directly the value of IC1. So IC1 will be what? IC1 will be 21 into 23.7 microampere. How much is coming IC1? Tell me.
0.48 मिलीएम्पियर,
0.48
मिलीएम्पियर।
milliampere. Tell me IC2.
IC2 9.66 मिलीएम्पियर,
I 9.66
मिलीएम्पियर, यस।
milliampere. So total current I will be how much? 9.66 plus 0.48. How much? This is 6, 10, 14, 6, 4, 14 and 6 for 11,
10.14 हो जाएगा।
10.14. Okay. And I'm saying this is 9.78. Okay. Whatever, just you can calculate what is exactly. So I'm putting here, what you're saying, I'm putting here 10.14 milliampere. Okay. Rest assured also can check. So VC will be now this 12 minus 10.14 milliampere, and this resistance is 1 kilo ohm. Okay, this will be cancelled out. So you get almost how much? 2 volts. Okay, almost 2 volts. 2 volt answer. So this, please check it again. This calculation may be something.
So the IC1 is how? 21 into 20 into
IC1 equal to
beta 1 IB1. So 20 into 23.7 into 20.
20 into. Okay, so how much will come?
ये सर, ये मिस्टेक हुआ, मैंने
0.44
21 ले लिया था।
0.4 सही है, is correct. 46 है, 46 milliampere है, 46.
सर 46 आया, यस सर, यस सर, 0.46।
46.
आई हैव टेकन 21, सो वो गलत हो गया था।
So 6, 6, 12. तो सेम ही है, तो ऑलमोस्ट सेम ही है,
अराउंड सेम ही आएगा।
अराउंड सेम ही आएगा. And IC2, this is 21 into 20.
into 0.023, 3 फैक्टर है, वो 9.66 ही आ रहा है।
ठीक है, okay. So almost it will come 2 volt. Correct. Mine, I'm getting 2.2 volt. Okay. You can do one time more calculations if
Yes.
this. So that is the thing. Okay. So this is your. So now you're saying transistor में कोई भी questions, any question transistor is very easy because you don't have a tough calculation, ना?
सर,
Yes, you. हाँ, tell me.
हमने ऊपर वाला क्वेश्चन कैसे बनाया है? BC इक्वल टू BCC माइनस I इंटू R, यहाँ पे
ये
अप्लाई किया गया?
ये वाला ना?
ये वाला सब BC इक्वल टू BCC माइनस
ये वाला,
यस
ये वाला.
हाँ,
भाई ये करंट आई है
यस सर,
और ये करंट कहाँ का यहाँ डिवाइड हो रहा है, यहाँ डिवाइड हो रहा है.
हाँ हाँ,
तो आई इक्वल टू IC1 प्लस IC2 है.
ठीक है, ठीक है।
ठीक है. अब ये VC कैसे आएगा, ये पॉइंट VC कैसे आएगा? ये वोल्टेज माइनस ये ड्रॉप, VC माइनस BCC माइनस आई इंटू दिस 1 किलो ओम ड्रॉप.
यस सर, यस, परफेक्ट। Thank you.
That's why I find I is equal to IC1 plus IC2. So you can use your own way, but only if you understand कि करना क्या है, okay. And I don't find any question in transistor you do mistake because of calculations, because the circuit is very simple. Okay, you just have to apply only KVL. So let us stop here, and tomorrow we'll see some other applications. The important topic is for you this operational amplifier. I think this transistor is very easy. One more important topic in transistor is AC amplifier. Okay, that we are going to see AC application of transistor that we'll do. Okay, so I'll stop here. Okay.
Thank you, sir.
Thank you, sir.